So I will provide a bit of background history, building up on what Joseph said, and I will describe a bit more in detail ASTROBEAT, which is the current project that is under development and that will go on board the International Space Station. So, as you know, I'm an aerospace engineer and pianist. The art part is important, very important for dissemination, and I will talk a bit more also about it, and explain you why. So, now, also thanks to the work of Joseph, this year Malta managed to upgrade its status in the framework of the ESA Plan for European Cooperating States. This means that now we can have access in competitive funds, of course, to much bigger funds than before, and hopefully in 4 years minimum, Malta can become a associate member, so not a full member, but the stage before, which would be already a great achievement. Now, quick overview, 2022, everything started thanks to Joseph, where I didn't take part as aerospace engineer, but as a musician. So, for public dissemination, with Joseph, we sent one of my compositions, Mallet, from the same name of the mission, which Mallet is a Phoenician name, old Phoenician name of Malta that can be translated as safe harbor. And I like this meaning because it can be referred like Malta is in the middle of Mediterranean and has been a safe harbor for centuries, so this beautiful island. Same thing, we can think about planet Earth being a safe harbor for the astronauts that will venture more and more into the expanse. This led to Mallet 3, where also MCAST became involved as official partner. And Joseph mentioned the qualification tests. Now I'm using that experience to build up for what it is ASTROBEAT, because ASTROBEAT is not a bioscience experiment, but many, many things are in common in the development of a space mission like this. So, talking about outreach, this led also to put together which was of experience, and what is in this book was also presented at different conferences, huge events that are including no more only the more technical part, but also the part related to space art. There is the biggest event in the world for aerospace, International Astronautical Congress. In Milano in October are expected around 10,000 attendees, so people in the field. And they have a full symposium for each day of the conference dedicated to space art and space outreach. So it's something big to keep an eye on for the future. Now, here you see an artistic rendering of ASTROBEAT before showing you the real photos. Before going to talk in detail what do I mean with a cold welding adhesion for spacecraft repairing, in a couple of slides I give a quick overview of the issue. So basically, as you probably know, since the first launch with the Sputnik, our, above all, the low Earth orbit, the orbit around our planet, started to become more and more polluted with what we call space junk or space debris. So in orbit, we have micrometeoroids that are of natural origin and space debris due to human activity. Now, it's true that in space there is a lot of space, but here we are talking about hundreds of millions of fragments that are building up during the years, which is the fact that the access to space is becoming more and more critical and dangerous, above all if you have a manned mission, so with astronauts. Plus, is putting at risk the missions that are already there, that if you have a catastrophic failure, can lead to the creation of more debris. So it's a serious problem that can affect our daily life. So, why are dangerous space debris? Just to give you an idea, you see that small sphere is 1.5 grams of aluminum, which is the most common material in space. At the range of speeds that you find in orbits that are of the order of kilometers per second, you have a huge kinetic energy associated with these impacts. So 1 little sphere like that, you can compare the energy delivered in an impact to a crash of a medium-sized car or the energy of a hand grenade. So is something really disruptive. Imagine a spacecraft, above all a spacecraft that has astronauts inside. So here is a laboratory test showing an hypervelocity impact where you have an aluminum plate, which is a classic simple shield for spacecraft, impacted at a high velocity, and you see the creation of a huge debris cloud that are further debris that can impact other structures, plus the generation of a hole. So they all thought about also be environmental friendly, as correctly Joseph said, is okay, nowadays, when something like this happens, most of the time you have to scrap the mission. What if, above all for human missions, we can repair that damage? So, here enters in the game ASTROBEAT, which is a project that is developing the prototype of an experiment to be tested on board the International Space Station, where there will be the testing of a phenomenon called cold welding adhesion, and I will go a bit more in detail about this. Before going more in detail, I wanted to highlight that this project is mainly funded by MCST, Malta Council for Science and Technology. As MCAST, the proposal that I submitted was awarded with the funds to develop this project. Plus, it's an international collaboration that sees Southeast Technological University that is in Dublin, and plus, more recently joined New York University Abu Dhabi, in particular the Center for Astrophysics and Space Service led by Professor Andrea Macciò. So it's an international collaboration, and on a practical point of view, the company providing the service is Nanorax, that now is called Voyager Space, that is based in Houston. And you have that basically my day is I'm working here with a Malta time zone, Dublin that luckily is only 1 hour behind, Dubai 3 hours of difference, Houston -8 hours. So it's quite a wide day in the management. So here is the team, so led by myself and Dr. Mark Wiley, which is in Dublin with Southeast Technological University. Mark Spiteri, that you know since he's a lecturer here and is a researcher about the project. Luke Farson, which is a structural engineer that is supporting the mechanical design part. Steve Boajar, electronic engineer that is developing the software of electronic. And Tiba Shafek, which is a master student at Southeast Technological University. Cold welding adhesion. In space, cold welding adhesion is a phenomenon that usually has always been seen as the devil. Why? Because basically in space, thanks to the particular conditions of microgravity and vacuum, metals, above all of similar type, when in contact, get stuck, basically creating this so-called cold welding adhesion that we can get also here on Earth, but we need a high amount of forces. In space, the forces needed are very small in comparison. So how humans discovered this phenomenon? The first example was in 1965 with one of the first missions from US, Gemini 4 mission, that saw the first EVA, extravehicular activity. So the astronaut of Gemini 4 went out, did the first historical spacewalk for the US. The colleague was waiting inside the capsule. When he had to go back, what happened? The hatch was not closing, was stuck. So they said, oops, we have a problem, serious problem, because you can't re-enter with that spacecraft with a capsule with a hatch open, of course, passing through the atmosphere. So luckily, with applying a lot of strength, the adhesion was still not complete. They managed to close the edge. So basically, they came back safely to Earth. There was also another mission in the 70s, a $1 billion mission, Galileo, that when it was arriving near Jupiter to study Jupiter, had an antenna that was umbrella-shaped because, of course, in a rocket you can't put something super wide. So it was compacted. When this umbrella shape, I'm simplifying a lot, was going to open, didn't happen, only partially opened. Why? Due also here to cold welding adhesion. So also that was a serious problem for something million of kilometers far from Earth. So now what we did, and this is why also we were successful in our proposal, we changed the point of view. And with Mark Wiley, we started in reality working on it nearly 3 years ago. We said, what if we use this to our own advantage? So there is an episode of Black Mirror where the same actor that did the Breaking Bad, Jesse Pinkman, in this episode is with another astronaut on a space station of a certain type, and there is a small emergency, and he goes outside to do welding. In the episode is a normal welding. But here we are passing from science fiction to actual science. So, as I was mentioning, with Mark Wiley, we started in reality 3 years ago. We started developing a first prototype last year, and Max Piteri went to Dublin to do the first test. So we started really from scratch. This also helped to win the proposal, and we arrived to what I will show you more in detail, to what is ASTROBEAT. So it's a 1 unit cube, so a little bit smaller than this, so they are both a very small experiment, where inside, basically there are 4 chambers that will test the application of different patches, we call, to test the cold welding adhesion to repair a hole. Here we didn't take real holes from a space debris impact. They are calibrated holes, everything is measured. So we want to verify that with the forces we are applying, we are actually able to fix this damage. So it is a 1 unit experiment. Our mass budget is very small, 600 grams, because in total is 1 kilo of a cube. We have a stepper motor, a mechanism that I will describe, an ohmmeter to read the measurement, because imagine you have 2 pieces of metal going in contact. You can measure the resistance. We have also has a Raspberry Pi and a camera to monitor the movement. So the core is represented by the 4 chambers. So one chamber basically is structured here like in the image, and the most important part is the one with the blue rectangle, where you have a plunger that is actuated by a spring. And you can see here 1 sample in aluminum, 2 samples, male and female, and 1 couple in copper, because we want to test both material. Why copper? Not because it is widely used in aerospace, but because for cold welding, there is at least some literature, and the properties are very well known. So we wanted to compare. And we will have 2 couples in aluminum and 2 couples in copper. And here you see the 4 chambers separately. I didn't bring here the cube today because in 10 days I will be in Houston at NanoRacks and NASA Johnson Space Center for the functional test, and exactly in these days the electronic is undergoing, let's say, surgical operation in the sense of the final soldering of the flight configuration for the contact. So wouldn't have been safe to take it out from the lab and having it going around. This will happen after the experiment comes back to Earth. So here is a photo while we were doing the test. You see also intermediate phases of the development of a cube with also some 3D printed parts to do preliminary tests. And here is a video rendering done by Skyup Academy, which is a academy in Italy that does high-level 3D projects for Hollywood movies, video games, and train people to do that. So they are one of the best in Italy and one of the best in the world. And they helped us to provide a artistic rendering of the experiment. Here, unfortunately, is a bit glittering the video, where you can see the exploratory view and the functioning of the experiment. So here you see in the top part there is the electronic. Here you have the plungers with the samples that I mentioned. On the back there is the camera, and here you see the functioning, where the stepper motor actuates those cogs and the springs deliver a force to the our samples where we want to be able to make the cold welding adhesion. Now, this is the 3D rendering, but we have also a video with nearly the finalized version of the experiment. Now, this is the flight model that soon will be tested in Houston, where you see exactly the same thing, but of course everything is assembled here. So this is a view of experiment, and here you will see on top one chamber actuated, and on the side the other two. Everything will be inside the cube, and on SpaceX rocket we will reach the International Space Station. So the experiment is targeted to be launched on the 17th of September, so very soon in reality. Working on this project is highly demanding, how Joseph correctly highlighted. There are a lot of requirements, a lot of deadlines that you have to respect. Otherwise, to put it in simple terms, NASA simply says you don't fly. End of the story. So simple as that. There is a different way of thinking in the space sector, and is very, very challenging, and luckily also very, very fascinating. So the experiment will stay 1 month on board the International Space Station. We will do in the first part the scientific part, so we will test our chambers. And after, there will be also the part related to space art and the dissemination. And here, now I will describe a bit. So, NYU Abu Dhabi is a part of New York University with a headquarters, of course, in New York. They are the biggest private university in the world. And I went there in Abu Dhabi. I was invited for a conference and also for an activity that now I will show. They have incredible facilities, and also they, thanks to Professor Andrea Macciò, they contributed to the project. Now is a first step for them to basically having the possibility of analyzing the data of the experiment, and is a very first important step for a future collaboration in building up for bigger projects. So I also presented ASTROBEAT at the Visible Certainty conference with very high level ranking people in the field, so it was a great opportunity. Plus, we are leveling up the part related to space art in 2 ways. One, in this case, yes, my music is going back to the International Space Station to be streamed from space to Earth. But in this case, the project, in particular with the composition Moonseed, got the interest of 2 top-level artists. So Tina Guo, cellist, and Steve Mazzaro, producer. In the music business, their name is huge, and they are collaborating since several years with a name that for sure you know, which is Hans Zimmer. So Dune, Interstellar, Inception, so we are talking about the best you can find in the world. And this, their support from the point of view of dissemination is amazing, because just think to the type of public you can reach disseminating these activities and what is literal space art because it's in space. So besides this, there is the part related to also involvement of students. So when I was at NYU Abu Dhabi, in collaboration with Professor Carlo Guedes, which is a composer, we organized a music contest for all the students of NYU. And two compositions were selected, having the commission also Tina Go and Steve Mazzaro, were selected to fly with ASTROBEAT and being streamed as well. Plus, there will be also a composition of Professor Carlo Guedes representing NYU. Moreover, I recorded there the music that will be in space. And basically there they have also, they teach also recording techniques and music production. So in collaboration with Professor Matteo Marciano and his team of Gazzini Records, there was also the full production of another composition of My Black Sun that is fully produced by NYU. So this was an experience for the students like you to be exposed to something different, something new, and something that for me and Joseph is now the present, and for you is the very near future. Plus, this of course helped hugely with the dissemination. So, undergoing the safety review with NASA in collaboration with NanoRacks. In September, hoping that there are no storms, no delays, the experiment will be launched. We'll stay 1 month, we'll come back to Earth. The experiment first will come back to Malta. Still, we will not put it for display because the samples that needs to be untouched will go to Dublin, where they have a facility with cutting-edge technology for metallurgical analysis. They will analyze the sample at a microscopic level to see the molecular bonding and the quality of this cold welding adhesion. And of course, when the experiment is in space, we will have preliminary data from the ohm-meter reader and the camera. After that, everything will be back again in Malta, and there will be an event where everyone will be able to see actually the cube. So that's all I have for today. Now, thank you for your attention. I hope that you found interesting both the projects. And now, Joseph, I guess we can have 10-15 minutes for a bit of a discussion, and we can also have your colleagues involved. Okay, thank you.
Good stuff.